Okay, the last thing we actually need to do in chapter 6 is evaluate normality. So we're going to collect data and we're not going to know if it's actually normally distributed. So we need some methods to perform that diagnosis ourselves. So that's what this video is about. The main way we're going to do that is to create histograms, which we're already familiar with. And we could just look, okay, does it kind of have a bell-shaped distribution? So here we kind of make this line around the histogram and we can see, okay, in this case, it's kind of got a bell-shaped curve. It looks symmetric. This seems like it's reasonably normally distributed. We know that if it's symmetric, the mean would also be equal to the median. And if we have the bell-shaped frequency, we know that this should follow the empirical rule. So if we were to say calculate the percentage of our data that falls within 1, 2, 3 standard deviations of the mean, well, it should follow the empirical rule, right? If we were to look at values between 1 standard deviation of the mean, we would expect to see about 68% of the data there, and so on. Another crude estimate is to just see if the range is equal to about 6 standard deviations, because we know that that should cover about 99.7% of the data. We could also see if the interquartile range is equal to about 1.33 standard deviations, which truthfully, I've never used these two methods, the 6 standard deviations or the 1.33 standard deviations. Really, I just use visual inspection. So box plots, histograms, normal QQ plots. We're looking for symmetry. We're looking for things that resemble more of a bell-shaped curve. So here's just one example over here where this is clearly not normally distributed because we're seeing that this has a high level of skewness, right? This is left skewness because we're seeing this peak is over here rather than like in the middle. So we would not call that normally distributed. And finally, QQ plots. So here are just some examples. So in this top left corner, so we have like a histogram that looks very normal. So the normal QQ plot, this is just plotting sample quantiles versus theoretical quantiles. Really, all we're looking for is a straight line. If this is about a straight line, then we would say that this is about normally distributed. Same with like down here. It's just has some fatter tails, and so we're seeing this line kind of pull away from, or these points pull away from the straight line. But we would still be okay with this. We're more concerned about lack of normality if these points are away from the straight line, but closer to the middle. So for example, these two plots over here. So if we look at the histograms, these are both skewed. So this first one has right skew or positive skew. Down here we have negative or left skew. And if we look at their corresponding QQ plots, we see that this is very much not following on the straight line. It's diverging quite a bit, and not just at the tail ends like in this bottom left QQ plot. They're diverging closer to the middle, both in both of these plots. So this would be a cause for concern in terms of normally distributed. But like I said, this is generally going to be something, we just create some plots, and it's kind of just up to us to determine, okay, is it reasonable to assume normality? And we're really just looking for any severe departures from normality.